Hey, Algebra 2 kids. Today we're going to work on graphing and writing equations of ellipses, and that's going to be exactly our objective. What I want to start with is, well, as usual, what do you notice, what do you wonder? We have these two graphs, and these themselves are ellipses, and I want to know, what do you notice, what do you wonder? So pause the video and maybe try and jot a couple things down or think about some things. Okay, and well, maybe after you pause the video, you noticed, well, in this ellipse right here, well, it seems to be, I guess in both cases, they kind of look like ovals, and in this case, it seems to be more horizontally oriented. And you notice, well, this is in red, so that might have stuck out to you, and this 2 is related to this, well, this point here, this point, and that point is called a vertex, and we'll get into the definitions of these things in either case, but you notice, well, when it's horizontal, this value is, this horizontal value, this vertex is x value is underneath here, and while this one's x value is underneath here, and this y value here of this vertex is here. So maybe you noticed a couple things, maybe you noticed something I didn't talk about, but in either case, we're going to move on to the definition of these equations, and they're in standard form right now. I guess maybe one more thing you noticed is that they're kind of centered at the origin. If this was an axis, I guess it should be labeled. It would be the origin. And you notice that this unit is always, it's going to be 1. So we're going to move to a couple definitions here. And then we're going to, well, start graphing some ellipses. So there's a lot of definitions here, and so my video isn't so long. I'm going to pause them, and I'm going to write them down. And I suggest once I write them down, you write them down in your notebook, and then we're going to discuss what they mean. Okay, I've written these definitions down. I'm going to read through them so you can actually read my handwriting. So an ellipse, the definition of an ellipse is just a figure such that the set of all points in a plane such that the sum of the distance between a point P and 2 points, the foci, is a constant. So what that means is if I have my 2 foci, we'll look at this one specifically on the right here. Actually, we'll look on the one on the left here. I have my 2 foci here, one here, one here. It just means that any point here, this was a point P, any point P, well, these distances, this D1, we call this D1, we call this D2. It just means that those distances, or the sum of those distances, is a constant. And we'll talk about how these might be related in a little bit. Okay, now that's the definition of an ellipse. Basically, it kind of just looks like an oval. And the foci are 2 fixed points on the interior of an ellipse. And if you look at these foci, you'll also notice they're in line with those vertexes, the vertices. So when it's horizontal, they're on the x-axis, I guess in standard form, and when it's vertical, they're on the y-axis there. Okay, so they're 2 fixed points on the interior of an ellipse, and these vertices, they are exterior points that lie on an ellipse. They specifically lie on the major axis. Now the definition of the major axis is going to change depending on what your ellipse looks like. So if your ellipse looks something like this, you'll notice that, well, what part is larger, the horizontal or the vertical part? And in this one, the horizontal part is larger, so that becomes your major axis. So your major axis is basically just the larger part of the ellipse. In this one, this vertical one, you'll notice that the major axis is vertical. It's the y-axis, since our center is at 0, 0. That's our origin. Okay, the center, in any case, is the midpoint of an ellipse. Midpoint, that should sound familiar. That might come into play. Okay, and the center, well, for any ellipse that's at the origin, center is going to be 0, 0. And co-vertices, okay, well, if vertices lie on the major axis, they're basically the exterior points of an ellipse that lie on the major axis. Co-vertices are going to lie on the minor axis, which is basically the opposite of whatever the major axis is. So if your major axis is the x-axis because it's horizontally, then your minor axis is going to be y. If your major axis is the y-axis, then your minor axis is going to be the x-axis if you're centered at the origin. Okay, so I guess I should read through these. The center is just the midpoint of an ellipse. The co-vertices are the 2 exterior points that lie on the minor axis, and the minor axis is just a line that joins the co-vertices. It's also, I guess I should say, it is perpendicular to the major axis. And, well, by that logic, the major axis is also perpendicular to the minor axis. Okay, now we have all these values, this A, this B, this C. These are all related, and we're going to talk about how these values are going to be used to graph these equations. But for an equation of an ellipse with a horizontal major axis, this one right here, the equation is going to be x squared over a squared plus y squared over b squared is going to equal 1. And your vertical major axis, well, it's going to be very similar. It's going to be x squared over b squared plus y squared over a squared equals 1. And what I want you to do, kind of pause the video, and if you can see if you can come up with a way to, well, relate these two equations. See if you can come up with a way to relate those equations. Okay, and if you've thought about it for a little bit, you might have noticed that these are very similar, except the a value and the b value are switched in these equations. And why is that? And you should notice that the a value corresponds with the positive, the positive value of the coordinate for the vertex on the major axis. So if you have a horizontal one, well, your vertex, your main vertices, not your co-vertices, your main vertice is going to be A. So whatever your main vertice goes under the x or y value. So if it's horizontal, well, it makes sense that since it's horizontal, the major axis is horizontal, that it will go under the x value. If it's vertical, it makes sense that the major axis, its coordinate value squared, is going to go under the y value. So if it's y, it's a major axis. It goes this way. You use the vertices. In either case, the vertice, in summary, goes under the value for if it's vertical, it's y. If it's horizontal, it's x, which kind of makes sense. Okay, so there's a lot of definitions here, and it seems kind of overwhelming. So let's just move to the standard equations. Write those down. Okay, I'm going to write these down, and then for the sake of saving time in this video, and then resume. So here we have a couple things written down. I'm going to read through these. So I guess one thing before we move on, I want to clarify. If you have an equation, some ellipse, x squared over whatever plus y squared over what equals 1, you can tell whether it's going to be horizontal or vertical by looking whichever value is greater. If the value underneath this x squared, this a, if this value is larger, whatever a squared might be, then it's horizontal. And if the larger value is under y, it's going to be vertical. And that makes sense because if you scroll up, well, if a represents some value, technically it's like the distance from 0, right? If this is going to be centered at 0, well, whichever value is greater, if it's underneath a or b, if it's underneath a, it's going to be horizontal because that value is going to be greater. If it's underneath y, that value is greater, then it means it's going to be vertical. And that might make sense with an example here. But before we move to an example, we need these things. So if it is in fact horizontal, its vertices are going to be plus and minus that a value, and its co-vertices are going to be plus or minus that b value. Okay, if it's a vertical ellipse, then its vertices are going to lie on the major axis, and since it's vertical, it'll go up and down, meaning its vertices will be on the y-axis. So it'll be plus or minus some a value that will be a y. And then your co-vertices are going to be on the x-axis, and they will be plus or minus this b value. Okay, so really just keep in mind whatever a is the larger number underneath these two this x squared or this y squared. It's the larger number. Then use that to determine things. And these are going to be related to, remember C is technically our focus up here. So we have a couple things. The major and minor axis have lengths 2a and 2b respectively. If you go up here, we have a distance of a. We have a distance of a. Well, that total distance should be then, well, 1a here, 1a here. That makes 2a. And this will be b if this is the minor axis. This will be b. This will be b. That makes 2b. So that kind of makes sense. Now here's the tricky one. The foci of an ellipse lies on the major axis. It's always on the major axis, and it's always a distance of c units from the center. And this is how it's related. C squared equals a squared minus b squared. So C stands for, I guess if I want to write this, I'm going to go ahead and do this. C is your foci. This is your major axis, or I guess it lies on your major axis. It will be your vertice. and this will be your covertice, or related to your covertice, I should say. And it kind of looks like the Pythagorean theorem, but it's not. And we're not going to be able to find arbitrarily how this equation is derived. Keep in mind that Pythagorean theorem is a squared plus b squared equals c squared, very similar, but those represent distances. I guess this represents distances too, but you want to know that this is not the Pythagorean theorem. And the way it's derived is kind of complex, so we're not going to worry about it too much. Just keep in mind that this is not the Pythagorean theorem. Not the Pythagorean theorem. This focus is a distance c from the center, and it's found by doing c squared equals and then finding your a value, major on your vertices here, a squared minus b squared, that value on your covertice. Okay, so let's move to an example. Graphing an equation of ellipse. And goodness, I didn't even write that. We want to graph, this is what we were supposed to start with. 4x squared plus 25y squared equals 100. And the problem with this right away is it's not in standard form. We want to get it into standard form, so what we have to do is get this value to 1. And how do I get that value to 1? Well, you divide technically everything by 100. And if I divide 4 by 100, that's the same as, I guess, we can write this 4x squared over 100 plus 25y squared over 100 equals, well, 100 over 100, but that's going to be 1. Okay, now 4x squared over 100, that's going to become x squared over 25. 25y squared over 100, well, 25 over 100, that just becomes y squared over 4. That's going to equal 1. Now, it's in standard form. And here's what we have to do. We want to find our vertices. I guess it should have said this. We want to identify vertice, covertice, and foci. Okay, now we know that our vertices are going to be on the major axis. Well, what's our major axis going to be? And since the larger values under x squared, we know that our major axis is going to be this. It's going to be horizontal. So this is going to be, well, this means a squared equals 25, b squared equals 4, and that implies a equals, well, plus or minus, I guess, 5. B equals plus or minus, well, the square root of 4 is 2. And we can graph those. And I guess I want to be careful here. A, our distance, is what A represents. So A is not going to be negative. You can't have a negative distance, so that was a mistake there. You can't have a negative distance. You can have a positive distance. So we know that A is going to be 5. Well, if we're starting at the origin, this is in standard form. 1, 2, 3, 4, 5. And 5 in the other direction. 1, 2, 3, 4, 5. Okay. And the reason this is going to become our major axis, this x-axis, because keep in mind, whatever value is larger, if it's underneath x, well, that's our major axis. If it's underneath y, our y is going to be our major axis here. Okay, and well, b is 2, so I go 1, 2 here, and I go 1, 2 here. And then you do your best to draw a perfect ellipse like I'm about to demonstrate. That could have been worse and it could have been better. All right, now we want to identify our vertices. So, well, our vertice, if this is a distance of 5 in the negative direction, this is going to be an x value of negative 5, 0. This one's going to be 5, 0. This is a distance of 2 in the y direction, so it's going to be 0, 2, and 0, negative 2. Those are our vertices. Those are our covertices. Now we have to find our foci. And our foci, remember from above that formula that kind of looks like the Pythagorean theorem? Our foci is found by, well, c squared equals our a squared, whoops, yeah, no, we're good, sorry, a squared minus b squared. So we know c squared, our foci, its distance is going to be equal to a squared, well, our a value is 5, so 25 minus, I guess I'll write that out, 5 squared minus, well, b squared is 2. So this just becomes c squared equals, well, this is going to be 21. 25 minus 4 is 21, which means C is going to equal the square root of 21. Now, technically, we should be saying, well, we're doing C. C is a variable. It should be plus or minus the square root of 21, right? But keep in mind that C technically stands for a distance. C is a distance, so distance can only be positive. We erase, whoops. No, don't do that. We erase this. It can only be positive root 21. Its distance can only be positive root 21. And keep in mind, the foci lies on the same axis as the vertices. It's on the major axis. In that case, it's this horizontal line here, our x-axis right now. And it is the square root of 21, which is about 4.6. So we go a distance of about 4.6. This is 4. That's about 4.6. Right there. This is about 4.6. Right there. Okay, so our foci is going to have a distance of, well, negative root 21 or negative 4.6 and 0, and positive root 21 and 0. Okay, maybe I should use some color coding. I'll make sure I do that in the next problem. So that's kind of how you do these. Basically, you want to find your A, your B value, and then use those to find your foci and plot those things. Okay, but you have to start by identifying what your major axis is. If the value underneath the x is larger, then your major axis is the x-axis. If it's underneath the y value, then it'd be the y-axis. Okay, let's move on here. Write an equation given a vertex and a covertex. We want to write an equation of the ellipse that has a vertex at 0, 4, covertex at negative 3, 0, and a center at 0, 0. Okay, well, the fact that the center is at 0, 0 is nice because we don't know how to graph something that's not centered at 0, 0 with the information we've been given so far. Okay, so write an equation of the ellipse that has a vertex at 0, 4. So it helps to just kind of plot these things. Its vertex is 0, 4. I guess one of its vertices is 0, 4. So up here. Okay, well, if that's its vertex, you should already maybe kind of know this is going to be kind of a vertical shaped ellipse. Well, if this is a vertex, we also know that this vertex must be 1, 2, 3, 1, 2, 3, 4 right here. There must also be another vertice down here. Okay, and its co-vertice is going to be basically on the side here. It's negative 3, 0. We can basically plot 2 points from there. So it's negative 3, 1, 2, 3, 0. That's not blue. You lied to me. There we are. Negative 1, 2, 3 here, and positive 1, 2, 3. So you can kind of see this is going to be going up this way. So it always helps in your progress packet. You might not have a graph, but it might help to kind of sketch one out just to see what's going to happen here. Okay. And our ellipse, we'll try that again. Our ellipse, well, it has this vertex, 0, 4. It has another vertex down here at 0, negative 4. It has a co-vertex at 3, 0, and another co-vertex at negative 3, 0, which we can just infer by the two given vertex and co-vertice. Okay, so basically we want to find our A value, we want to find our B value, and your A value is always going to correspond with your vertex. Your A value is always going to correspond with your vertex. Well, it's obviously going to be 4 here, and our B value is going to be, well, 3. Our distance is going to be 3. Okay, so to write the equation, well, that's easy enough. We know it's x squared over plus y squared over something equals 1, and whichever one, I guess you have to think, well, what's my A value? Your A value is 4, but what does it go under? And since this is going to be kind of, your major axis is on the y-axis, since this is a vertical ellipse, you know, since it's on the y-axis, your larger value goes under y. So this is going to be 4 squared, this is going to be 3 squared. So this becomes x squared over 9 plus y squared over 16 equals 1. That's our answer. So that one's actually not too bad. That one's not too bad. We're jumping right from example 2 to example 4 here. So we want to write another equation, but we have different information. We want to write an equation of ellipse that has a vertex at -8, 0 and focus at 4, 0. So let's, once again, it always kind of helps to just graph what's going to go on. We have a vertex at -8, 0, and I did vertexes in green, so we'll stick to that. So at -8, 0, well, 1, 2, let's go by 2's. -2. So 2, 4, 6, 8, right here. Well, if it has a vertex at -8, we also know it has a vertex at +8. 2, 4, 6, 8. Now, we don't know what its covertice is, but we know it has a focus at 4, 0. It has a focus at 4, 0, so right here. Here's a focus. Here's a focus. And here is a focus. Okay, well, how does this help me? How does this help me? And I'm going to label these here. Well, we know we can relate these quantities how? Well, what's my A value? What's my B value? What's my C value? That's what we want to find. That's what we want to find. And just, well, how are those values related? We know, I don't want gray, I want black. We know A squared minus B squared equals C squared. That's going to be hard to get used to. Keep in mind you were working with ellipses here. Your brain's going to want to say A squared plus B squared equals C squared. But we are not using the Pythagorean theorem. We're just trying to relate these quantities when we have a distance C for our focus, distance A for our vertice. We want to find our distance B for our covertice. So basically plug in our values. We know A is going to be, well, it's related to our vertice. So it's 8. It's the distance of A. We know C's distance from the center is going to be 4. So basically plug these in, find what your B value is. That means 8 squared minus B squared, we don't know what that is, equals C squared, well, equals 4 squared, which means, well, negative B squared equals 4 squared minus 8 squared. I'm just moving this over by subtracting it, which means negative B squared equals, well, 4 squared is going to be 16, 8 squared is going to be 48, which means, or excuse me, 8 squared is going to be 64. So if I do 8 squared, whoa, hold on. What did we do? Are we good? A squared, 8, B squared equals C squared. We're good there. Okay. So 4 squared minus 8 squared should give you negative 48. We're good there. Divide by negative B squared. It's going to be 48, which implies B is going to be the square root of 48. And you might be thinking, well, B squared, we're solving for a variable. It should be plus or minus, right? But keep in mind, this is representing a distance from the center. So it can only be positive square root of 48. And if you simplify that, that's, I guess, 4 root 3. You can factor out the square root of 16 there. Or you know that distance is about, well, it's just a little bit more than 7. If you plug that into your calculator, I actually don't know what that is. I don't have the calculator handy. Let me go get one. About, this 4 root 3 is about 6.92. That's going to be our B value, so we can use that. I guess we don't need to write an ellipse. Excuse me, we don't need to graph this ellipse, but if you wanted to, you certainly could. It'd look something like, well, 2, 4, if we're going by 2's to keep this uniform. 2, 4, 6, 8, it'd be about there. Be about here. And 2, 4, 6, that'd be about right there. Just about 7. So your ellipse would look like something like this, but we want to just write the equation of the ellipse. We want the equation of the ellipse, which means we need to, wow, that's not an all-time great ellipse, but that's okay. We know x squared plus y squared equals 1, and this is going to be over something here. Well, x squared over something, y squared over something. You have to think, well, where's the larger value going to go? Under the y or the x value? And since this is technically a horizontal ellipse, it's going to go under that x value. Okay, so our major axis is, well, 8 squared plus, okay, what's our b value? Well, technically we found b is 4 root 3, or it's the square root of 48. It's the square root of 48, and we're squaring that. So just to rewrite this, this is x squared over, well, 8 squared is 64. The square root of 48 squared is 48, so plus y squared over 48 equals 1. So in these problems, you want to find your you want to find your A, your B, your C. Keep in mind that A corresponds with the vertices, B corresponds with the distance of your covertices, C is the distance of the center to the focus. Okay, so find those quantities, and then you can write an equation. I hope to see you guys on our Zoom meetings if you have any questions, and I'm going to upload this video to Google Classroom here.